Alright, you guys, this is my 8th hour geometry class. You guys gonna do so much better, right?
Yes!
Alright, woo, look at it, amazing.
Yes.
Hear that energy.
I'm on YouTube. Hold on, do I
World
look
Star,
good,
wait, no, YouTube? Yeah. You don't yell YouTube, you kind of like people do with World Star, right?
Yeah.
It's not the same, you don't yell YouTube.
Wait.
Okay, anyway. Alright, so we're going to translate pre-image. Pre-image means that I'm going to translate it starting there. Then after the translation, it's going to be the image. Now, what do I know about the shape of these two things right here?
They're the same.
They're the same. So I could say, what is the math term for being the same?
Congruent.
Congruent. So they're going to be congruent. These are going to be congruent. Now, this one right here, when I'm talking about translations, what type of movement is that? Is it a flip, a slide, or a rotate?
A slide.
This one's a slide. Okay, this one's going to be the slide, right? So now, if I know that these are going to be congruent right here, I know that this is going to be a rigid, so I'm going to write it up here. Transformation. So that's going to be a rigid transformation. So this is going to be the vector. So the vector is going to be the direction also. Okay? This means that it is, with these little alligators right here, it's not a coordinate, it's a vector. So that means that if it's positive 3, it's going 3 to the 3 to the right. So that's what we're doing over here. Okay, 3 to the right. So what if it was a negative 3? Go to the left. Very good. So now, since this is positive 5, it's going to go up. It's my y value, right? So it's my x, comma, y. So this one moves my x values. This one moves my y values. So 3 to the right, 5 up. Let's see. 3 to the right, 1, 2, 3. 5 up. 1, 2, 3, 4, 5. Super easy, right?
Yeah.
All right, so let's go ahead and keep going. So because of that, we also have the words for this. Shift the triangle 3 units to the right and 5 units up. So we're moving the whole thing. 3 to the right, 5 up. 3 right, 5 up. Yes? Make sense? Now there's another type of notation that we're going to have for this, but now it's going to be from point to point. Because we're going to require you to know multiple ways of actually reading this or writing this. So whatever my x value is, so it's going to look like this. X, comma, y is going to be translated. Now, what am I doing to the x value? Going 3 to the right. So what does that mean I'm going to do?
May you please repeat the question?
Okay, so if I'm going 3 to the right, what does it tell me I'm going to be doing?
Right.
Okay, so now, what's this x value? So if I start at negative 8, right?
Yeah.
It goes to negative 5.
So that's going to be negative 5. But what did I do there? Mathematically, what did I do?
You should
Add how much?
3.
So now it's going to be my x plus 3. It's going to be my x value plus 3, right? Now, what am I doing to the y value? So it's going to be y, and it's going up, isn't it? It's going up. It's going up how much? So I'm going to put y plus 5. So this is another way of writing my notation.
Yes.
Okay, because this gives me point by point. Where this just tells me the direction of everything, so I just take the whole thing and move it that way. This says, hey, this coordinate here, I'm going to move it there and there, right?
Yes.
Okay, so let's do the math on this now. So the coordinate A is located at negative 8 and negative 5. So if I start at A, what am I going to call the next one?
B.
Nope.
A prime.
Excellent. Good job. A prime. A prime. So now what am I doing to my x value here?
Adding 3.
Add 3, so I get
Negative 5.
Negative 5. What am I doing to my y value?
Adding 5.
Adding 5, so I should get
0.
that make sense?
Yes.
Okay, now let's do the next one. Let's do b. So b is located at negative 6, negative 2. What am I going to call the transformation?
B
B
prime.
prime.
B prime. So, add 3, so what am I going to get?
3.
Negative 3, right?
Yep.
So to the x, I'm adding 3. And now, what am I getting for the y value?
Positive 3.
Positive 3. Whoa! Is that good?
I like it. Sorry.
Alright, let's do it again. So last one's going to be my c. Where's c located at? Negative what? Negative 5 and negative 5. So I'm going to call this one my c prime. So let's go ahead and do my math. So I'm going to come up with what? Negative 2 and 0. Negative 5 plus 5 is 0. So I can verify that my coordinates are where they're supposed to be at here, right? I did the math on it here. I verified the coordinates here. Very easy, right? So yes.
Yes.
Okay, good. Now, I'm also going to tell you guys one more thing to go along with this because it goes along with what we did, what we're going to do later on. But I'm going to come back to this here in a minute. Now, state the meaning of the vector in words. So what does this say? So what does that mean? Say it again. 3 to the left.
Yes.
And 1 up. Right? Okay, what about number 2? 6 to the right. 2 down. Super easy, right?
Are you knowing this to the right or to the left?
Positive and negative.
Alright.
So if you're looking at my graph, my positive numbers are on the right hand side, right? Negatives are on the left. So if you're going bigger, you're moving to the right. If you're going smaller, you move to the left.
Alright.
So positive and negative right there. All right. Where am I at now? Okay, draw the image. So I'm going to rewrite this first. So let's write it, use my coordinate rules.
5 to the negative.
Coordinate rules.
Oh, my bad.
X comma Y is going to be what? What am I going to write?
X plus
X minus 5, very good. X minus 5 and
Y
plus 4, very good. So now that I have my coordinate rules right there, that means I'm going to go 5 to the left and 4 up, right?
Yes.
5 to the left, 4 up. So now I wrote out my coordinate rules, so now let's go ahead and do this. So I'm going to just verify it on my graph. So let's do this because we've done it by the math, and now let's just do it by the graph this time. So 5 to the left, 4 up. 1, 2, 3, 4, 5. 1, 2, 3, 4. I put a dot there. What do I call that? A prime. Do the same thing for each one. Let me see for B. 1, 2, 3, 4, 5. 1, 2, 3, 4. Want B prime. 1, 2, 3, 4, 5. 1, 2, 3, 4. That's the D prime. 1, 2, 3, 4, 5. 1, 2, 3, 4. That's my C prime. Alright, so next thing I'm going to do, I'm going to actually explain to you the distance it traveled. Okay, because this is actually going to be one of the questions later on. Because this, it's actually, it's a little triangle, isn't it?
Yes, what is that symbol?
So right here, this is going to be a little triangle. So that means it's, my triangle goes left 5, right? And it went up 4. And so I'm going to be looking for the distance. I know I have another card here. Here it is. I'm looking for the distance from here to here. That's going to be the total distance traveled. So this is the distance I'm going to look for. What method of math? Pythagorean theorem, right? Pythagorean theorem. All right. Let's go ahead and do Pythagorean theorem, please, to find the distance traveled. So let's take a look. It's going to be, let's see, I'm going to have 4 squared plus 5 squared equals distance squared. Making sure I'm still on the thing. 16 plus 25 equals d squared. 41 is equal to d squared. How do I undo the square? Square root. So d, I'm going to rewrite this, equals square root of 41. So d is going to be about, so in my calculator, that's where you put it in, right? 6.4. Does everyone agree? Does everyone actually know how to get that? Because I'm going to put it on the calculator just so you guys see it.
That's going to be a decimal. That's
Yeah. So control. So I'm going to hit control. X squared is going to give me the radical. And put your 41. Yeah. There we go, right?
that's
6.4. So the distance it traveled is going to be 6.4 units. So each one of this, so from B to B prime is going to be 6.4 units. From A to A prime is 6.4 units. D to D prime is, and C to C prime is. Is that super easy now?
Yes.
There we go. Okay, don't forget, I would say like, share, and subscribe, but we haven't got that far yet. All right, so I want to explain this one right here. This one, they gave you the vector this time. They gave you the vector. So there's a couple things here. So this, my printer doesn't like triangles, so it writes little boxes instead. So fix those. All right, so this is starting here, and it's ending here. So if it starts here and ends here, if it starts here, so let's go. What is it moving to the right? It's moving to the right, isn't it? 1, 2, 3, right? So I would say that that vector is going to be positive 3, and it goes over 3, but what else does it do now? Oh, I'm sorry. Sorry, there we go. So it was positive 3, and now down 4, right? Down 4, I put what? Negative 4.
I said it first.
There we go. Who said it first? You did? Hey, I got something social for you. Okay, I got a snack here in a second. Why you gotta make it weird? Alright, so I'll let you guys do this. Okay, now look, I want you guys to see this, please. Listen. Hey. When you get down to 2 right here, find the length of the vector. And shouldn't that be the same as the length here?
Yeah.
It should be. That's what I was trying to prove here. Each one of these is actually moving the same thing as the vector. Make sense?
Yeah.
Good. All right, like, share, and subscribe. Thank you. All right. Good job, you guys.